goes. Hi, Amy. How are you doing?
Hi, sir. Yes, I'm doing very well. Thank you. How are you?
Good, very good. So today, what do you want to do?
We kind of moved on to a new chapter. So we've moved away from the mechanics and we're going like more towards statistics, where they do a bit of conditional probability. So again, I think this is the topic that I found you first with,
Nice.
because I find probability like tricky. So yes, that would be really helpful if we could go through it.
Sure, sure. My pleasure. So do you want to share some questions, or like how do you want to go about?
Yeah, I could share my textbook if that's
Sure.
okay.
That's good. That's good.
It's got to be done. There are these things called like tags because we're not sure whether exams will happen and everything. So the end of year exams and things. So every little test that we do in between, they want to make sure that they will take into account. So I have to actually understand everything quite well.
Of course, of course.
Yeah, right. So yeah, these were the questions. Do you want to start right from the beginning or?
Anywhere, doesn't matter. Slightly earlier will be better. Yeah, conditional probability. So you understand conditional probability. It means something has happened, and then what happens? If this happens, then what? Correct. So that is conditional probability. So they are actually beginning with giving you based on set notation. Venn diagram is a good thing to. So this is a prerequisite for conditional priority. Correct.
Yeah.
So the first Venn diagram, which I see here, is showing you the intersection of A and B. So the yellow portion highlighted is common to both, and therefore that is the intersection. And as you know fairly well, this will be represented as A intersection of B, right?
Yeah.
So that is a symbol for intersection. Now, there are the events, right? So it says the intersection of A and B is written as A intersection B. If A and B are independent events, then their intersection is product of probability of A with probability of B. So that's a very important condition there. So whenever you have intersection, then the probability of intersection of both these events, right, is the product of these individual events if and only if they are independent, otherwise not. Okay, so that's a very important. Yeah. Now the other one is the union, when everything is included. So in this case, we are saying probability of A plus probability of B gives you the union of these two things. Now, that is the case only if they are mutually exclusive. Do you see that term, mutually exclusive?
Yeah.
So two important terms which have been pointed out here are independent. So independent means the two events are independent if and only if the probability of both these events with an and condition, so intersection is and, is equal to the product of each probability. Okay.
Yeah.
And the second one is the union. And in union of A or B, this is like OR operation, right? So this is your AND operation, and this is your OR operation. And in this case, mutually exclusive means that the diagram should be like, let me just draw it here on the side. If I draw like this, these two circles, right, then they are mutually exclusive. They have nothing in common. You get the idea.
So if they're independent, do they have something in common?
No, independent is irrespective of that. Independent is like throwing a dice and then spinning a spinner, right? So these two are independent events, right? So, but when we say, there could be, when we say, if you get 6 and on the spinner, you get an even number, then you get that much point.
Yeah.
So then you're connecting, right? If you get 6, right? So that is a condition, correct? So it becomes a conditional probability. So if I have to write probability for the given situation, in this particular case, the union should be written as, so I should say this statement here on the right is kind of misleading. I should not say wrong. Will be probability of A plus probability of B, but we have to take away the common point, right? Because when you add probability of A and B, that intersection has been added twice.
Twice,
So,
yeah.
so we have to take away probability of A intersection B, right?
Wait,
Now,
so why didn't they write that there?
no, they wrote mutually exclusive, but it's confusing. So this is general case, right? So this is not mutually exclusive.
Oh, so if it's not mutually exclusive, to find the
We have to take away the common area, right? So we also call this as inclusion, exclusion, right? You may. So whatever is included in both has to be excluded because we
okay.
So either way, you should try to remember this, correct? So that is how it is. Now let's also look into the notation which is written here. Can you please read that?
Yeah, so if two events A and B are mutually exclusive, then their intersection is the empty set. So you can write, A and B equals.
So in general, this is the right equation because if they are mutually exclusive, then we know this is an empty set, right? So you're not taking away anything. So you have probability of A plus probability of B. So strictly speaking, we should have included here probability of A times probability of B, right? I mean, intersection B, right? Is it okay?
Yeah.
Because if they are mutually exclusive, in that case, their intersection is null set, so you don't take away anything. Are these points absolutely clear to you?
Yeah.
Okay, so let me clear this and you can move along and see what is the next step. Another very important thing, which is the complement. Yeah.
You meant.
Where are you? Right here. Can you please read this?
So the event not A can be written as A complement. A prime. It's also called the complement of A.
Correct. So you can, either way. So basically, probability is 1 of everything happening. So complement is 1 minus probability of something happening. That will give you something not happening. Correct. So that's another very important relation which we need to consider, right? So let's move on from here. Correct. You can take up any examples you want. Okay, Venn diagram. Yeah, we'll focus on Venn diagram. That's a good idea. So question number 2, let's see. On copies of this Venn diagram, shade A union, not B. So let's try to understand how do we do that. So we have to figure out what is not B, right? So B is given to you, not B is outside. Do you see that not B?
Oh, yeah. So not B is the outside. What about A? Yeah, including A.
And now we are including A in it, right? So A is included and not B is included. So if as soon as you include A, you include this portion also. Do you see that?
But that portion wasn't part of not B.
Yeah. So, but you are saying whatever is not B is also included and whatever is A is also included.
Oh, okay.
So whatever I have shaded in now is included. You get the idea.
All right. Okay.
Union. Union means or. This or that.
Oh, I see.
That is the correct answer for A union, not B. You understand now? Clear?
Yeah. So you need to do one part first, and then because it's union, you add whatever else.
Everything shaded now is the solution, correct? So what is not the solution is the intersection has been taken away from B, right? That is not the solution. You get the idea. So the intersection has been taken away from B, right? That is not the solution. So not of this is that. Okay, now, second one. So you have made a note. I'll erase this now.
Yes.
Let's do not A, not B. And we are looking into intersection of these, right? So let me use light colors and then we can highlight. So not A means everything going outside. Do you see that in green, correct?
And B. Yeah.
So we'll do in turns. So first we are saying not A and then we are saying not B. So not B means all this. Do you see that?
Not B means outside and A.
Not B means outside B. Is it okay?
Yeah.
And you want intersection. So you want where it intersects. So which is the portion where both are there? This is what
The outside.
So the outside
Only.
of both. Do you see that? So it is basically the outside of both. Do you see that?
Oh, yeah. I see. So, oh, it's hard to show on paper without doing it the way you're doing it.
Not as simple, correct?
Yeah.
So it is, you could write this as it is union of outside. Is it okay?
Yeah. And then overlap of both
So
is the outside.
A union B, not A union B. Do you see that? We could write this as not A union B, because what you did not really highlight is everything which was A or B. You get the idea?
Yeah.
So now you
So there's two ways of writing the same thing.
correct. And that is how it works. It is like not, that means if you open this bracket, the sign reverses. Do you see the change in sign? Sign becomes not union means intersection. Is that okay?
Yeah, yeah.
Right? And A and B complements. Not A, not B. Do you get the idea?
Yeah.
Not A, not union means intersection, and not B. And that is what it means.
Right.
You get the idea?
Yeah, that's clear.
Let's do the next one, which is we will first do A intersection B and then find its complement, right? So A intersection B is basically given to you
Center.
as the center portion, right? And the complement is everything outside. So excluding this, do you see that? So
Yeah.
not shaded portion. I can write not shaded portion. Is it okay? Is the answer for this. Is that clear to you?
Yeah.
If you want to shade it or shade it in red, right? If you want to shade it, well, let's do it.
Will be the outside except the green part.
Yeah, except the green part. You reminded me. I was being very careful. Except the green part. Yeah, that's it. You're right. So everything except that green part. Perfect.
Wait, sir. So can that part C be written as A dash U B dash? So A not or.
A, not A, not B, and
the sign switch.
Does it make sense? So let's do it. Not A. So if I do not A, I'm going outside this, right? Not A, correct? But I've included everything in B except for the intersection. Do you see that? Not A.
Right.
And if I do not B, except for the intersection, I have shading everything now. Even the portion of A, which was earlier not shaded. Is that clear to you now?
Oh, yeah.
So what remains is yeah, oh, sorry, is this, right? So you see now how to open the bracket and understand complement, union, intersection? Easy?
Yeah. I first thought that, yeah, because I didn't really understand it before. When you take that prime, I thought you do A prime N B prime, but that's not the same as that bracket. The sign would switch. Yeah. So now I understand. Yeah.
Perfect. Okay. So now let's do this 3 together and all.
Yeah, it's quite hard with 3. I found it tricky. So yeah, this will be helpful.
So let's look into the intersection of A and B and shade that up. So A and B intersection is this one, correct?
Yeah.
A and B intersection. And now we want to include union of C. So let me take another color to include everything in C, right? So C, everything in C will be this. Is that clear to you?
Yeah.
So when you do union of one with the intersection of the other, that is how you get.
I see. So it's this part plus all of C.
All of C. So it's
Right.
always good to use colored pens for doing this particular exercise. Now, let's look into union and intersection. So when you want to do intersection and union, let's do the union first. So union of not A, not B, right? So let's do that.
Oh, because
Of-
that's the same. Because that's the same as A and B
Yeah, the
whole
first thing.
complement.
Correct.
Yeah,
The first
we can
portion,
use
right?
that. Yeah.
Well, anyway, let's do it now. Not A and not B. So that means, let me just state, not A means here outside. So we carefully, we are shading not A first. Not A.
Mhm.
Now we are saying not B. So not B means, so the intersection remains and everything else is, let me draw one more green line here, just to not A. Let me draw here also. Now I'm using blue color for not B. So outside B. Outside B means that. So we are taking union of these two, right? Everything which has color in it has been included. That means the only portion which is not included at the moment is the intersection of
Center.
A and B. Is it okay?
Yeah.
Now we have to see what is the intersection of all this with C, correct? So let me just add intersection with C. So the C, everything in C except for that small little thing. You understand?
Hmm.
So everything in C except the common portion for all three of them. Do you get the idea? So what is not included in this particular case is this portion, which is basically A intersection B intersection C. Do you see that?
What about the bit above it? Is that included? No.
Yeah, no, not that, not that. Oh, sorry, yeah, you're right. So yeah, that is also not included. Yes. That is not included. So A union A intersection B union C. Right. Yeah, that is not. Sorry. This is wrong. Wait. Yeah, that is also not included. Correct. So when we do this intersection with C, what is not included is everything common to either A and B, basically. Not included is the intersection of A and B.
Why is all of C included though? Why is it not just the two parts that intersect with A and B?
Oh, because it was not A, that portion of not A had B in it, union B, right? That portion had A in it. You get the idea. Not B had not A in it.
So not B had not A.
Yeah.
Um,
So the first portion which you did was basically everything except for, this was everything except for A intersection B, right? Do you understand?
yeah, that part makes sense.
So it was basically this.
So everything but the center.
But
no, like the center
common
section.
thing, right? And now with that, we are doing intersection of C. Do you see that? So now everything except center, and now we'll include C into it. Is it okay? So the only portion of C without the common portion which even came within the C. Do you understand now?
So how do you know when to prioritize what? So if it's N, does that mean you can't enter the center? But if it was U, can you enter the center?
U means or. Or means you can have everything. Me, what I possess and what you possess is all included, right? That's what it is. So now we are saying we want to do what is common between the first part and C. Already in the first part, that middle portion of C is not there, that small portion.
Yeah.
So we cannot include it.
Yeah, that's clear.
That is why. So when you have the whole thing as shown here, have a good look at it and one full C. So if something is missing in C, that portion which is common A, B, that means we are looking into this kind of an expression. Or you can say
Right.
intersection of, not either way you could write. You get the idea.
Yeah. Yeah.
So not the intersection of AB with the intersection of C, because that portion is excluded from C also.
Yeah.
That is
That
what.
makes sense.
Correct. So I think that's clear. Okay. So anything else?
Also, do you mind if we could go through C?
Yeah. Sure. Oh yeah, yeah. Oh my
While
God.
we're here. Yeah.
Right. So we want to ultimately have a complement, and it is A intersection B intersection not C, right? So A intersection B will be what? Let's go one by one. So A intersection B is this, right?
So the centers, yeah.
Yeah. And then we want to do intersection with not C. So if I do intersection with not C, so that means I'm only left with this portion. Is that okay?
Just the top part. Yeah.
Yeah. Intersection with not C, because this was common, right? So this is intersection with not C. This is the inside part. Do you understand? And now it says everything except that. Everything except that.
Oh.
So the answer
So you shade everything except that section.
except that. Do you understand?
Okay.
So
Yeah.
in the earlier case, we had that thing not included here, but now it is not included on the other side.
Right. Right.
That's the idea, right? So as soon as you bring this inside, it kind of becomes.
So do you have to always work inside to out when answering these questions?
Yeah, because
Like,
yeah, of course.
okay. So it's everything shaded but that red section.
Yes.
Okay.
So they did every intersection. So basically, if you observe carefully, so the center portion basically has been written as this. Do you see that?
Oh yeah.
Because the complement is outside. So this complement will be
It's the
A
same.
complement union B complement, right? I could write this as A complement union B complement union C.
Right. It's because there's so many ways to write the same thing.
Right.
Yeah. All right. So that makes sense. I think I've understood that part. Yeah, I think these are just some more questions. I can have a go at that now because I think
Sure,
I
sure.
understand. Yeah,
Very good.
what that is.
So your set is over. You understood all these set things? Let's take some examples from this side. I give
right.
you pretty important examples. Yeah. So don't rush to conditional probability now. Let's be very clear about mutually exclusive independent events and using these Venn diagrams in word problems. It is very tricky.
Okay. Yeah.
We have just done the shading. Now let's try to understand. Question number 9. Can you please read question number 9?
Yeah. So A, B, and C are three events with the probability A as 0.55, probability of B as 0.35, and probability of C as 0.4, where the probability of A and and C is 0.2. Given that A and B are mutually exclusive and B and C are independent, part A, draw a Venn diagram to illustrate the probabilities.
Okay, so we are saying, given that A and B are mutually exclusive, that means if I sketch A and B, I have to sketch like this. Is that okay?
Like away from each other.
Away from it, yeah.
And C in the middle.
And A and B are mutually exclusive, and B and C. So let me write A and B here. A and B are mutually exclusive, and B and C are independent. So when they are independent, so okay, so C could go in general. Let's put C like this. Let's put C like this. Is that okay? The second condition. Let's put like independent basically means that probability of B and C is product of their individual probabilities. You understand?
Right. Yeah.
Now,
When they say B and C are independent, though, because they haven't mentioned A, you don't have to put the C on the right-hand side of the B and then leave the A completely out. You can
yeah,
say
yeah,
attach it.
you have to put a general case, right?
Oh, okay.
Begin
Okay.
with, yeah, to begin with. So yeah, so that is independent, right? So draw a Venn diagram to illustrate the probabilities. Okay, fine. So this is one kind of a thing which I have. Let me just put this in a box, right? So when you're making a Venn diagram, you have to make an outside box. And what do you write outside? S or U? What do you use symbol?
That E sign.
E sign, right? So
Yeah.
that's correct. So either one you could use. Perfect. Now, draw the Venn diagram to illustrate the probabilities. Find the probability of A not B and all this, right? So probability of C is given to you as 0.4. Let's go through this. Probability of A intersection C is 0.2. So this is 0.2. Do you see that A intersection C is 0.2?
Mm-hmm.
Probability of C is 0.4. And probability of A, so what we have to, we can from here find probability of C intersection B. So what is the probability of C intersection B? We are saying
The probability of B times the probability of C.
Yeah. So multiply. So probability of C is 0.4. And multiply this with probability of B, which is 0.35. How much do you get? 35, sorry. Yeah.
0.14.
0.14. So this is 0.14. You get the idea, right? 0.14. It's kind of tricky, right? Those conditions. And now the probability of C can be written as what? Probability of C is 0.4 in all. So how much is this portion? So from 0.4, take away these sum, right?
Yeah.
0.2 and take away this.
0.06.
So that is how you're going to get all this. You get the idea?
Yeah.
Now you can write probability of A is 0.55. So 0.55, take away 0.2.
0.35.
And probability of B is 0.35. So you get what?
0.21.
So that is how you're going to sketch this Venn diagram. Is this clear to you?
Yeah. Do we need to add them all up and do one subtract? Make sure.
What for? No, don't waste your time.
For the outside.
Oh, for the outside. Oh, I see. Okay, do that. Check that. Yeah, you're right. Do that. Good.
Okay, I'll do.
Add all these which you have written here and see what you get. Yeah.
0.96.
Oh.
So 0.04. Outside.
That's very good point, Amy. Good job. Correct. Now, find the probabilities of each. Now, because you know all this, sharing and all, you can actually do the rest, correct?
Yeah.
However, this was 4 marks and that was very important question. Okay.
So it couldn't have been done without using the formulas like you did there, knowing that the product of both.
Correct. Independent, you understand that the intersection is product of the two probabilities. Mutually exclusive is nothing in common. Null set is common between the two, right? That's what it is. So that's how we are going to do part. Okay, question number 9. Rest, I think, are very easy. You can do that, right? Now, try once again. Question number 10. Amy, can you do it now?
Yeah. So, sorry, I've got the hiccups. It's really annoying. Okay. A, B, and C are 3 events with probability A as 0.25, probability B as 0.4, probability of C as 0.45, and probability of A and B and C as 0.1.
Okay. So
given that,
So
given that A and B are independent, B and C are independent, and A and not B and C is an empty set, draw the Venn diagram.
So I think you should try all these questions and then move on to the next.
Okay.
Okay, great. So we'll end the class here for now,
Yeah.
right? And then we'll continue with conditional probability in the next class. So,
All
Anil,
right.
can you summarize what did you learn today?
Yes, so it was kind of a start or introduction to set notation and trying to understand the ways of shading the Venn diagrams in terms of mutually exclusive and independent and not mutually exclusive Venn diagrams as well. Just understanding those key terms and like even just seeing like we always see the usual like two circles being overlapped, but this time it's involving three. That's why it's much trickier. And also the new notation of the empty set. So when that comes in, you kind of have to understand. So like the last question we saw, it's easier to start with finding the intersection probabilities and then from there trying to draw the diagram. Because if you go straight to drawing the diagram, it can keep changing because your probabilities won't line up. So yeah, you have to keep like trying different ways until you figure out what it's supposed to be.
So if you draw a general diagram, you could write 0 there, but then, you could erase and then do some correction in the
Right.
picture. So it may not be oval shaped or circular in nature. You could just make some correction and, you could do that.
Yeah.
If you find 0 probability between the two, right? Okay.
That's true. Yeah.
So that's great. So we'll end the class here. Amy, see you next time.
All right. See you, sir. Thank you so much.
Great. Thank you. Have a great day.
Thank you. And you, sir. Bye.
Bye.